Okay, welcome back to video 2. Now that our circuit is set up, we need to simulate this and see if we can get those current, voltage, power values. Let's run it. Hopefully we will not get any errors or warnings. Let's wait for 50 seconds because I have set the project runtime as 50 seconds, so that is why it takes around 50 seconds for the simulation to run. Looks like we do not have any errors, but at the same time we are also not getting those voltage, current and power values. So we need something called a multimeter. We can insert that in series with the resistor and the power source to get those values, and we can connect it like this. The terminals should be connected with the multimeter properly, otherwise it will not work. We also need to configure the multimeter to show those values. So double click on the multimeter, we get this window. We need to say yes for all of these because we definitely need those values to be shown. Let's keep this digital yes. And this integrates. We also need this animated display yes. Clicking OK. Now if I run this project again, I will be able to see the rectifier, the active power, and also the voltage. Let's reduce the duration of the run to 0.5 seconds. Let's do things quickly. You will be able to see that the power, the active power and reactive power, you can see in actual real time, because Pscad is a time-based simulation software. It solves differential equations, which are time-based equations, which is why you would see that these values dynamically change as the time progresses. So that is why the value was 0, and then it started from 0 to 2.6 into 10 power 4 watts, and the reactive power is minus 5.318 into 10 power minus 15, which is very, very small. Since this is just a resistive load, there is no inductive load, which is why the reactive power is almost negligible. The voltage, which is the line-to-line three-phase voltage, is 230 kilovolt. We can also find and plot the current, and for us to do that we need something called signals and prods and data graphers or loggers. So I will also show you the current calculations for this one. The current is basically 230 kilovolts divided by square root of 3, because this is a three-phase line-to-line voltage. So that divided by the resistance, which gives us around 63.7 kiloamps. That is a huge amount of current that is going through this resistor. Now we need to configure this multimeter to show us different quantities in the graph. So double click on this, expand this window so you can see everything clearly. Go to signal names. Now we need to give all of these signals proper names so that we can then view them in the grapher. I will name them as I go. VRMS, this is the line to line for the source. You can name them anything you want, but this is just what I follow normally. The naming is done. Now next we need is to grab those signals and show them in the grapher. So we need something called a data label. Now the name of this node or this signal name should be exactly what we chose for all of these signals here. So the best way is to come here and copy all of them and paste them one by one there. So this should be my I_inst. We also need something called the input and output device, which is this plot or meter channel. This is basically the output device because it will give us the output of this signal, and this signal is being taken from this multimeter. So this is how this is working. We need a cable to connect these two, correct? And then click on this. You can also give them give this meter a name, so that then once we plot them, we can actually see the actual names and distinguish between the different quantities. Now just copy this, paste again, because this is essentially the same components we're using over and over again, just with different signals and different names. It's done. Then we need one for P and Q. This should be P with active power. This is also P. Then we need one for Q, reactive power. Again, you can show those quantities with any name you want and just follow the normal convention. This should be the VRMS underscore L underscore source. Copy all this because we need this in the output as well. And then we don't need the phase, so don't worry about that one. Now I will right click on this one, go to graphs, meters and controls, add overlay graph here. So now you can see the I instantaneous is getting its plotting data from this meter. Now if I run this again, I will be able to see the current in this graph. I can do the same thing for the voltage, the power, the effective power. Let's we can do something like this, Control C. Click here so that the active power and reactive power are in the same graph, up and down, and then we can also see the voltage in a graph, and the way I can do that is like this. Now if I click on run, I will be able to see some graphs and some data there. Now this data is out of bounds, so I can right click on this and make it reset, so then I can actually see what's going on. This is the instantaneous current. It's a sinusoidal way, which is why it's going up and down. The mean or average point is 0, as you all know. Same goes for the voltage. We can reset these things, and this is also instantaneous. Let's also reset the extents for the power as well. You see this is drawing this amount of power. It ramps up in this time and then it becomes constant. The time is on the x-axis, so we can see that. You should also do the same for this one, and since the reactive power is very small or negligible, you will see something very different here. then the voltage source, three-phase line to line. This is also ramping up, and then it becomes constant at 230 kilovolts. So that is all for this video. Stay tuned for next videos. I'll be adding some switches, circuit breakers, automatic circuit breakers, as well as manual circuit breakers, so that you can have an understanding of how Pscad works.